Okay, so welcome everyone. I'd like to present you a bit about my thoughts on GitOps and security. But first, who am I? My name is Reto Bollinger. I work here as Information Security Officer, and I maintain the Information Security Management System. So what you know by ISO 27001 and the QMS 9001. And in that, I have a bit the role of the good and the bad cop in one person. Somehow, I hope most of you know me as the good cop. And my attributes, slightly paranoid, but that one I compensate by being a bit reclusive. I'm a bit reclusive, but that one I compensate by being a bit overly communicative, like holding talks and such. So welcome and thanks. So, what is information security? Information security is CIA. Yeah, CIA. No, actually not that CIA, but confidentiality, integrity, and availability. Basically, everything about information security is around confidentiality, integrity, or availability. So confidentiality, that your data is kept secure and that basically do not give access to anyone who you do not want to give access to. Integrity, data is not worth anything if you can't be sure that it's not modified unwanted. So you want your data to be integer and not modified unwanted. And availability, of course, you need the data to be accessible when you need it, but only conflicts a bit with the confidentiality, available to you and to those who should have access, but only to those and not just to the whole world. So, how does it look like if you have ops, DevOps, SecOps, DevSecOps, and confidentiality? So, possible scenario. Hey, I need to have quickly access to that data. Yeah, sure, I can give you. I will just adjust the permissions quickly, and afterwards I will revert them. And where there is the asterisk, you can add in one of the following, either nothing, or if you have some configuration management system, of course, first you have to disable that because that always interferes with your modifications and tries to revert it. Or if you have even some policies, probably you first need to get approval for disabling the configuration management system and then disabling it and modify your data. And yeah, time passes by. 12 months later, hey, why is that data accessible to the whole world? Who the fuck, messed with the permissions? And why? Let's check the logs. Damn, the logs last only for 6 months back, and the change has happened before. No clue why that stuff was made accessible to the whole world, and in what context? Forget about it to find out. Of course, because the revert later was not done at any point. How does it look like with integrity? Let's quickly check the log files. They are in such an ugly format, so let me strip that unnecessary stuff from that log files. And then, hacky on the console, do some fancy in-place ugly command, which goes recursively over the whole directory. And unfortunately, you have your configuration files also affected. And that's the point when you realize the config files in that state they are not revision controlled, but manually adjusted. And how do you now revert that change that you made? Because, of course, it's immediately applied. Integrity is compromised. Availability. We have that new brand new version of the app. We roll it out, and while rolling it out, we find out, oh, there are so many dependencies. Yeah, those are going to be updated because we have a package manager who updates all the stuff. And yeah, everything is now at the latest version. And at that point, probably find out it breaks everything. And yeah, now how to roll back and to the original version, because you have updated all the packages and everything, and could be quite hard to roll back. Does anything of that sound familiar to some of you? I see some smiling faces, some hands raising. So yeah, I think we know that. And now for something completely different. We go a bit back in my history, a story from my former life. Yeah, I had a life before I went to 9. So my life before I went to 9 involved a lot of such things like embedded hardware with embedded software, of course. So we have a firmware that is loaded onto some hardware. The firmware consists of an application with the configuration, and the application is not only programmed on bare metal, but we use an embedded OS with libraries and drivers and everything. So that's the whole firmware that we load onto that stuff. To build that, we have a build system, continuous integration, continuous delivery, because yeah, it's quite a lot of software despite being in a small device. So we built that stuff, and the build system, it runs on an OS with a lot of packages. And now comes the big challenge. Yeah. How likely are you to be able to rebuild that stuff exactly, the binary, bit by bit, in 5 years from now? So basically you build the software, and the business I was in, it was in military business. There you have some long-lasting contracts, and they include that at some point later, at some point in time, they want you to be able to rebuild the whole software, the whole firmware, and only do really small modifications afterwards. So you have to be able to rebuild the whole stuff 5 years from now. And of course, in the meantime, the build system changes. The OS, of course, is also getting updated, even the LTE, most probably. Yeah, so how do you do that? We need GitOps, I think. GitOps, because we have a lot of dependencies. We have multiple repositories. As I showed you, those thingies were in different repositories. If you go back, we have a repository, at least that's how we solved it, a repository where the OS and the build system together were in one repository. The configuration and the application was in a repository, and also we tracked the OS and its packages in a binary repository. So we had 3 repositories that had to somehow work together, and yeah, we had to rebuild we had to be able to rebuild the whole stack with the build system and everything from scratch. We have multiple repositories with their own histories and revisions. And we have additional configurations. Each customer has its own configuration of the software that is also tracked in the repository, but yeah, has to be made sure that it's in that repository. And we have even data that relies on specific revisions of the software. For example, databases, if you update the database, the database software, sometimes there were changes to the database format, so everything is really together and can only be changed as a whole. So we have to track all that stuff somehow, and we did that by describing the state of each repository, of the configurations and whatever, and tracked that in a separate repository where we just set that repository on a certain revision, and yeah, all of those repositories that were involved in certain revisions together with the configuration files. So everything there was tracked in one repository, so that we do not depend on anything being changed at some point and not being tracked. Okay, that was in the past. Let's go back to the cloud, to now, and yeah, that's how we now have services or software. We have a deployment consisting of some services, and it's defined in, call it a YAML. It's any can be any system, but most often those files are YAML files, so they are describing the whole deployment. And now you have also the monitoring, and what happens now if there is a disruption or a change or a disruption, and how we do change that so that we quickly have fixed the software or the service so that it's kept running. Yeah, we have a disruption, the monitoring alerts us. We realize, oops, it failed, so we SSH into that instance, into that service instance, and yeah, fix it. For example, we make everything, the initial example that I had, we make everything accessible to the whole world. And yeah, of course, that stupid alert that's always showing up, we silence that. And yeah, so service is running, monitoring is silenced. Yeah, let's continue. Yeah, unfortunately, that service is now insecure because we made the data accessible to the public, and the alerting is completely silenced because it was so annoying. We silenced it. We have no track of that. Yeah, once we update the service 2 to a new revision, probably that problem reoccurs because we fix it only in that instance. And once we roll out the whole deployment again, that change is gone, and we have probably the initial problem that triggered the whole sequence again. And probably could also be that it breaks even more if we roll out a new revision, or that because of that change we have some subsequent modifications to the data that was not tracked at all. So yeah, it breaks afterwards even worse. So let's go the GitOps way, assuming the same. So basically we have here now, as I said, we have everything deployed, defined in the YAML. The deployment goes through the CI/CD. Of course, that was the case before as well, but now visualized a bit better. And we have the same, yes, the same. Disruption, so we have the disruption and the monitoring alerts. And yeah, let's SSH into it. No, that's not how it works. GitOps is about not touching that instance, but only probably look at it, why it's broken. But we do not work on that instance, but we work on the YAML file. So we edit the YAML file, we push it, and then it is rebuilt, and we have the deployment in a proper state, in a well-defined state, which is defined in that YAML, and we do not work on that stuff at all. So basically, if you have it implemented correctly, I think you guys at the platform teams do it, that you do not have, at least not by default, direct access to the individual instances. You want to tell me something? Some dirty secrets? Yes. But the goal should be that you do not have direct, at least not by default, direct access to that instances, and that you're not going to modify those. So GitOps means we declare everything, so that the whole deployment we have declared. We do not depend on some manually applied changes in the deployments. We should not depend on any external states, but declare the states. And if we depend on anything that is really relevant to the setup, we have to declare that as well and track that as well. And we work only on the declaration, but not on the actual instances. However, looking is allowed. As I said, sometimes probably there is a need for digging into the issue and analyzing it, but then you should consider that instance tainted and not use it anymore in production afterwards. So ideally, you define also the monitoring and the configuration. And In a perfect world, also the continuous integration, the configuration for the continuous integration, everything described in some files and in a repository. And basically, when you do a change, when you do that, when you roll that out, you have everything described here. So basically, the CI/CD can build the whole deployment, the whole setup from scratch. And we declare everything what we need. And yeah, we have to think about how to bootstrap that whole thing, because initially there is no CI/CD pipeline there probably. So that's some tricky part. We should then test not only the incremental changes. So if we have a change to one of the service, so we should test how it behaves from one step, from the current step to the next step. But in worst case, everything breaks down. So we should also test, can we rebuild that new state from scratch, and basically test that from scratch as well. And we want to keep a mirror of the public repositories, at least if you want to have, if you have some long-lasting requirements like we had in the previous company for 5 years. Probably your binary repositories are also not accessible anymore. I think for that, for our fast-living world, that's not so important. But if you have something long-lasting, some obligations there, then probably you want to have that stuff in a mirror as well. And we use unique identifiers, and not only probably the tags that are often used, they are not necessarily unique. If it's properly maintained, most probably they are, but yeah, most probably. So now, how is GitOps good from security perspective then? Yeah, the CIA, keep that in mind. C, confidentiality. One can still accidentally misconfigure permissions, for example. Could still, even if in the YAML, if you do it via GitOps, could still happen. But for one, it's documented and traceable. And then there are the merge requests, which require approval, 4-eyes principle. So someone should probably notice that you may have made some mistake there. And you could even automate some stuff that you, for example, check for suspicious patterns in that merge requests or anything. So that improves the security that you make a mistake and accidentally or even intentionally compromise confidentiality. You can reduce that risk quite a bit. And of course, direct access to instances can also be restricted, should be restricted at least for modifications. That also helps to keep the confidentiality, that you do not accidentally misconfigure something in your running instances. Integrity. One can no longer create inconsistency, because if you have really declared everything, there you will always end up with the same state if you recreate it, and you do not end up with some inconsistency because everything is declarative. So integrity is guaranteed. Availability. Yeah, that's a tricky one, because either it runs or it doesn't. And if it does not run, we revert to the previous state. Of course, now someone raises his hand and said, yeah, but I'm way quicker if I fix it via SSH in the running instance and have less downtime. Yes, for that moment, you have probably less downtime, but there is the risk that by applying that change and having that change in there, at a later state, you have bigger downtime, and that risk is then mitigated, of course, at the cost of having a bit longer cycle time if you have a fix that you want to apply via the revision control. But yeah, ideally you can revert just to the previous state, then take your time, fix it, and roll out. And yeah, that's what I said. And the quality should be better, because again, you have the merge requests that are approved and that are thoroughly tested, ideally. My thoughts, on that. I see Ramon always smiling somehow. I think I have to have a closer look at the platform team. My thoughts, what makes a good GitOps project from security perspective. So we have no, or at least only read only. I call it back-end access to the running instances. A back-end access, I mean the SSH access into the instances. We have automated testing, so we test everything, and if we find a new way how to break it, we can create a new test and fix it, or basically have a regression test, and that case will never ever occur again because it's being tested. When we're doing automated testing, ideally we can have incremental and bootstraps tests. So basically that we not only change the incremental change, but also the change from scratch if we have to recreate a new state from scratch. In the automated testing, we can find edge cases and robustify against these with chaos engineering. So basically there is nothing speaking against running some random tests, some chaos engineering, just shutting down randomly any instances. And if important is, if you find anything there, document it and have it as a new test added to your automated test, because otherwise there is no use in chaos engineering. Merge requests should follow the 4 eyes principle. So basically that it's a merge request and someone else has to look and approve it, and I called it 4+ eyes principle. So 4 eyes is at least, and there can even be more required if it's something important. Then we should have a well-defined scope so that we know what do we want to declare, what is declared, and where are the boundaries. And the boundaries can be from outside, that I say I rely on that distributor to provide me the packages, for example, that I rely that this distributor is there, that I do not have my own local mirror, but it's well defined. I have that as a requirement. And what is also important, that I have inverts, I call it inverts, basically the outer dependencies, but also inverts. I have some boundaries where if I have a managed service where the customer runs his stuff, and that I basically have well-defined boundaries, whereas I am responsible for providing you that setup, and what you do in there is yours, is your responsibility. But I test everything and have ideally a fake customer who does probably also some chaos engineer or chaotic things, some instance that I can run on my setup, which finds me then some edge cases. So, but that I have really well defined also where the boundaries are towards the customer. And yeah, for the chaos engineering, there is a good talk by Dan Akristini. So. Any questions? Yeah?
I have no idea of this GitOps thing, but how are the YAML files generated, or any?
I think that the important part is not how they are being generated, but that everything is described there, and that they define the whole setup. So they can be manually, or depending on what software you're using. Most probably there are tools that create that can create at least partially or even to the full extent. Yeah, that can create those. But depends.
Maybe can we give an example how we do it in your team? Oh.
I mean, yeah, we have everything in a ton of Git repositories, like 50, 60 by now, and we track everything through tags. I would like to have actual commit hashes, but we're working with tags now, and a central versions log file that describes the state of the world in the end. Then we just deploy everything from the state that's defined in that version repository. So that's how we bind all these repositories together.
Yeah, it's exactly. It's that is basically what glues everything to what defines the whole state. Yes.
Having talks about a monorepo since forever now, which would solve a lot of problems, but would create new ones.
Yes, exactly. I think both can be done the GitOps way. Yeah.
You said that Git tags are not unique. What did you mean by that?
Basically, I'm not referring only to Git, but at least in Mercurial, we could change basically. First, we tag one revision with some tag, and for example, revision 1. Then we modified which should actually be revision 1.1, but at some point, some clever guy came to the idea. Yeah, we almost did not roll out that version 1, so let's redeclare the new revision to version 1. So he applied the tag to the new revision, and if I rely at some point because that's possible, if I rely that that tag is unique and sticky to that unique revision, probably unique is the wrong word, but it's It's redefinable. Yes, exactly. Sorry, yeah, that was expressed wrongly. Yeah.
Actually, in case there are fat tags and regular tags, if you have a fat tag, it's like a branch. No, it's not like a branch. It's a real Git object and it's stable, right?
Yeah. So. Yeah, basically, yeah, exactly. But because it's not, there is not only Git. Of course, it's called GitOps because Git is the most popular one. I just wanted to emphasize that basically you should not rely just on a tag on its own. Yes. Yeah. Thanks. Okay. So, sorry.
How do you monitor attacks, let's call it attacks, or malicious operations on this, let's call it GitOps system, for example? How can you trust that the information in the Git, let's say the history, holds true? If I'm admin on that repo, I can force a different system?
Yeah. That one is not covered by the I have no I have no solution for that right now. But yeah, it's a good point. It's not the universal solution for everything. It just reduces the risk to a smaller set. But yeah, right. Yeah, good point. Does not help against malicious admins or something.
Yeah, it's a trust-based system.
Yes, still,
like the CI/CD
yes,
admin can still
yes, of course, yeah, he can get everything through. Yeah. Okay, so I think there is some speaker waiting for in the line to queue up. So.
Good. Thank you, Reto.
Thanks.